Okay, so hello everyone. Hello everyone. Hello. Okay, guys. So let's start our videos. So in this video, in this live session, I will try to explain some questions which can be asked in interviews. Like the first question they can ask you is how we can reduce overfitting. So this is a very classical question everyone asks. So how we can reduce overfitting? Okay, so it is overfitting. So how we can reduce overfitting? So there are various methods. The first method we can use is early dropping. Early dropping, not early dropping, early stopping. So it is a method where we stop our model. Like let's say we used 200 earlier, and we got an accuracy of 91%. Then but after that, let's say I'm using 1000 epochs, and here the accuracy becomes 93%. So see here, from 200 epochs we increased our epochs to 1000, but our accuracy only increased 2%. So there is not a much increase in our accuracy. We can make this accuracy 91%, but we significantly reduce our training time if we use 200 epochs. So the first one is 200, where we can reduce our accuracy a little bit and reduce our training time. So this is one of the method. And the second method is regularization. So there are various ways to regularize. The first one is L1 regularization, then L2 regularization, and then elastic net. So what is elastic net? So in elastic net we use L1 plus L2 both. And what is L1? L1 means lasso, and what is L2? L2 means raise. So what we do in this regularization? In this regularization we add a penalty term. We add a penalty term in the loss function to large weights. Okay, and the third method is we can use cross validation. So cross validation is basically used to generalize the output of the model. We take we take averages of various models. So by this way we can generalize our model. Okay, the fourth one is we can use dropout. So dropout is a technique where we drop neurons. So it is basically used in deep learning, where we drop neurons randomly. So this will help us to generalize our model. Okay, the fifth one is simpler models. So these are 5 techniques we can use to reduce the overfitting of the model. Okay, the second question they can ask is how to reduce underfitting. Okay, so how we reduce underfitting? So first of all, what is underfitting? So underfitting is when our model perform worst on training dataset and on testing dataset. On both perform worst. Then we can use various techniques for that also. The first one, we can use more complex models to increase our accuracy. Okay, the second one, we can add more relevant features. Add more relevant features to the model so that our model learns well. And third, we can reduce regularization. In the first one, where we wanted to reduce overfitting, there we used regularization. But if we want to increase our model, then we can reduce regularization, like over, if we regularize our model 2, then we can do this also. And the fourth one, we can train our model for longer time, so this will also increase the accuracy. Okay, the third question we can ask is, what is regularization? Okay, so what is regularization? So regularization is a technique which is used to reduce model complexity and prevent overfitting. And what it do? It adds a penalty term to the loss function okay. So what are the types? The first one is L1 regularization, which is also known as lasso regularization, and the second one is RIZ, and the third one is elastic net. Okay, and what is lasso? So in lasso, in L1, we would add the absolute value of rates, adds the absolute weight as penalty. Okay, in L2 we adds the square of weights as penalty. Okay, then in elastic net, in this we add both techniques. We add both L1 and L2 to balance both the feature selection and weight reduction. Okay, so here in L2 regularization, like in RIZ, we add square of the weights. So what it does, it reduces the large weight but don't eliminate it. So what it do, it reduces the large weight's importance, but didn't eliminate it. Okay, and what L2 L1 does, it reduces large weights. Okay, so the L1 what does, it shrink some of the weights to zeros by perform feature selection. So this reduces some of the weights to 0 and perform feature selection. Okay, then the fourth one, it can be a follow-up, so they can explain lasso and RIZ regression. Okay, so the lasso regression is mean squared error plus lambda summation of modulus of, and this comes. So what is mean squared error? So the mean squared error is basically yi minus y predicted chi-square upon the number of features. So this is our mean squared error term. Okay, and what is RIS? So the formula of RIS is mean squared error plus lambda I is equal to 1 wi square. So this is our term. So here lambda is regularization term. Okay, what L1 do? L1 do feature selection. And how it do feature selection? So it reduces some of the weights to 0. And what L2 does? L2 reduces the importance of large weights by reducing them, but didn't eliminate them. So this is the difference between both two. And here comes elastic net. So elastic net is the balance between L1 and L2. In elastic net we add both the terms. So what it does, it balances the feature selection one and also the weight reduction. Okay, so it is very useful when our features are correlated. So elastic net is very useful when features are correlated. Okay, then someone asked, so this was his fourth question. The fifth question, someone asked that what are different types of model evolutions. Okay, so what are model evolution types? So where the first model evolution type is test train split. So here we split our data into 80% training and 20% testing, or 70% training or 30% testing, and then we train our model on 80% of the data and then take accuracy, and then we take accuracy on the 20% of the testing data and then compare whether our model is performing best on the unseen data. So this is a evolution technique. The second one is cross validation. Okay, so here we split our data into k folds and then train on k-1 folds and validate on the remaining folds and average results to reduce bias. So here we split our data into k folds, and then train on k minus 1 folds and test on remaining one, and then take averages on output, which generalizes our model. Okay, the third we can use is confusion matrix. So confusion matrix is used for classification models. Then the fourth technique we can use is by calculating accuracy. Then the fifth technique we can use using precision. Then recall, this is the sixth one. Then we can use F1 score. Then we can use ROC curve and AUC, loss functions. So these are the techniques which we can use for model evaluation purposes. The sixth question someone asked is explain confusion matrix. Okay, so what is confusion matrix? So basically confusion matrix is a evaluation technique. Here we have true values, or you can say predicted, and you can see take anything where we have predicted values, and here we have real values. This is actual true, actual false. This is predicted true, and this is predicted false. So this one is known as true positive. This one is known as false positive, because our model is saying positive, but in actual it is false. In actual it is true. So true positive and false positive. Then here comes our true false. Okay, so this one known as false negative, because our model is giving a false signal or a negative, that's why it is negative, but actually it is true, that's why it is false. So it is false negative. And here the model is telling it is a false, and actually it is a false, so that's why it is a true negative. So these are predicted, so that's why it is true for positive and true false, and this one is true negative. So this is our confusion matrix. So true positive means it correctly identified our model. Then false negative is in this case, positive cases incorrectly predicted as. Okay, so what this means, here we have true positive. This means that our model correctly predicted. So here true positive means our model correctly predicted positive cases. Okay, so this is very better for us. And then comes our true negative. So what is this? Here our model correctly predicted negative cases. Okay, then here comes false positive. Here positive means model predicted positive, but in actual it is negative, so that's why it is false positive. Here our actual cases are negative, so this means negative cases here negative cases incorrectly predicted as positives. Then here comes false negative. What this means? False means okay, so why this is known as false? Because our model predicted false, but in actual it is true. Okay, so here false negative means because actual cases incorrectly predicted as negative. So where our model incorrectly predicted there, so that's why we are telling a true negative and true and false negative, and here our model predicted as okay. So this is our confusion matrix. Then here comes the seventh question. So the seventh question is, what is the difference between precision and recall? Difference between precision and recall. Okay, so the formula of precision is how our model is precise. Okay, so we can calculate is using true positive, means how much our model is telling the truth, and then true positive, and then false positive. Okay, so this is our precision. And what is recall? So the formula of recall is true positive upon true positive plus false negative. Okay, so what and there here it comes a term F1 score. So what is F1 score? So F1 score is 2 into precision into recall upon precision plus recall. So it is F1 score is a harmonic mean of precision and recall. Okay, the seventh question they can ask is, what are types of loss functions? So there are various types of loss functions we can use. The first loss function we can use is MSE, which is mean squared error. The formula of MSE is 1 by n. Basically we are taking averages, then y real minus yi predicted chi-square. So this is our mean squared function. So what it does, so it penalizes the large errors. Okay, so it penalizes the large errors more heavily. Then the second one is mean absolute error, MAE, which is known as mean absolute error. What is the formula of mean absolute error? So the formula of mean absolute error is modulus of yi minus yi predicted. So this is formula. What it does, so it is less sensitive, to outliers than MSE. Then the third one is Huber loss. What it does, it combines both MSE and mean absolute error. Both is combined here. So what it does, it also very less sensitive to outliers. Okay, then here comes the fourth one, which is cross entropy loss. And where we can use it, it is used in classification problems. We can use it in classification problems. It measures the difference between predicted value and the actual levels. So the formula of cross entropy is minus 1 by n, then summation of I is equal to 1 to n yi log yi plus 1 minus log y 1 minus 1 log 1 minus yi predicted. Yi log yi and the fifth one is hinge loss. It is for classification with SVMs. So hinge loss is used for classification with SVMs. Okay, so here it is used for classification with SVMs. It includes maximum margin between classes. Okay, so it is hinge loss. It encourages maximum margin between classes. Okay, the sixth one is we can use KL divergence. Then eighth one is we can use R squared. The formula of R squared is 1 minus summation of yi minus y predicted ka square upon summation of yi minus y bar ka square, where I goes from 1 to n, where I goes from 1 to n. This is R squared. Okay, so these are the techniques we can use for our loss function. The first one is MSE, which is mean squared error. Then the second one is mean absolute error, which is mean where we are using modulus of differences. Then we are using Huber loss. So Huber loss is a combination of both MSE and MAE. Then we are using cross entropy function, which is used in classification models, basically in logistic regression model. And what is the formula of cross entropy? So the formula of cross entropy is 1 upon n, 1 upon minus 1 upon n summation of yi summation of log yi. Okay, so summation is outside, so minus 1 by n bracket में summation of I is equal to 1 to I, then yi log yi predicted plus 1 minus yi log 1 minus yi predicted. So this is our cross entropy function. Then here comes as hinge loss. And what is hinge loss? So hinge loss is used for classification with SPMs. Hinge loss is used with SPMs. What hinge loss do? So hinge loss encourages maximum margin between classes. And here comes scale divergence, which is used for probabilistic models. Then here comes R squared, which we can use with linear regression models, where the formula is 1 minus summation of yi minus yi predicted square upon summation of yi minus y bar square. Okay, so here comes our 8th question. So what is our 8th question? So the 8th question is accuracy always a good metric for classification? The answer is no. And why it is? Because sometimes accuracy can be misleading. Sometimes accuracy can be misleading. When data is unbalanced. So in this case we use precision, recall, or we can use F1 score. So these are best techniques. Okay, the 10th question is, what is cross validation? Okay, so it is a model evaluation technique which is used to test how well a model is performing. Okay, so it is a model evaluation technique used to test how well model generalizes to unseen data. Okay, so it is a generalization technique. So it is a model evaluation technique which is used to test how well a model generalizes to unseen data. Okay, how it is used? So here the first step is we split the data set into k folds. Let's say we have 1000 data, then we divide it into 200 into 5 sets. Okay, then second step comes. In this we train the model on k-1 folds and test it on the remaining fold. Okay, then we repeat this process k times. So every fold is used, okay, for testing ons. Then we take average. Then we take average of all results. As final performance. Score. Okay. So there are various types of cross validation. The first type is k-fold. Okay. Then the second one is stratified. Where it is used in classification. Then comes leave one out. It is a special case. Where k is number of samples. And here every point is act as test set ons. So what we do in k-fold? So in k-fold we do, like, we have 1000 data set, then we divide into 200, 200, 200, 200, 200, 200 of 5 sets, and then in this 200 we train our model. Okay, so on this we train our model, on this we train our model, in this train our model, and this train our model, and test on the one. But in leave one out, we use one as testing, one data set as testing. But here we are using 200 data as testing. Okay, but here we are using one data as testing sets. So this is the difference. Then comes fourth one. Then comes fourth one, which is hold one out. Hold out method. And what is hold out method? So it is simple: train, test. Okay, so these are the four methods of cross validation. The first one is k-fold, and then stratified cross validation, then leave one out, in which we are using a single data set as testing, and then fourth one is hold out method. Okay, so this is our 10th problem. Then what is 11th? So 11th question someone maybe ask. What is the difference between regularization and standardization? And normalization. So these are various techniques. So the regularization is used to reduce overfitting. Here we have L1, L2, then elastic net. These are the three techniques in regularization. So L1 is lasso, it add absolute terms. Then L2, it is raised, it uses square, then elastic, it uses both L1 plus L2. So L2 reduces model weights, but it didn't go to 0, but in L1 we reduces some of the features to 0. So what is standardization? So standardization is a pre-processing step. It is a pre-processing technique. So it is a pre-processing technique that rescales features our features. So they can have a mean of 0 and standard deviation of 1. So this is our conversion. We apply this on every data, and then comes normalization technique. So it is also a pre-processing technique. So it is a pre-processing technique. It also rescales. But here the range is fixed between 0 to 1. Okay. The formula here used is x minus x minimum, x minus x, x max minus x. So this is a normalization technique. Here we rescale our features between 0 to 1, and here we reduce our features so that their mean is 0 and standard deviation is 1. Okay. The 11th question they can ask is, what is feature engineering? Okay. So feature engineering is a technique where we create, process of creating, transforming or selecting relevant features. From raw data. To improve the performance okay. So it is a process of creation. So feature engineering is a process of creation, transforming, and then selecting. So these three processes we do: we create our features, we transform our features, we select our features to increase the performance. Okay. So these are the key features. So the first one is creation. We create data. Like in creation we create new features from existing ones. Then transformation. Here we apply scaling normalization, or mathematical transformation. Okay, so we can scale, we can normalize, we can transform mathematically, like using log these. So these are the transformation techniques. Then we can use encoding. Here we convert our categorical variables into numerical forms. Like one hot label encoding. So these are various encoding techniques where we use our categorical variables into numerical ones. Then comes feature selection. So in feature selection we identify and keep only the most relevant features. Using techniques like correlation, mutual information, or model based. Okay guys, so these are the various questions they can ask. If you like this series, then you can comment here and can ask for more these type of questions. So goodbye, thank you.